Welcome to Get Your FRQ On. This is question 3C from the 2000 Calculus AB exam. We're given the graph of a function f prime, and we are asked to use it to determine and find all relative minima of the function f of x on the interval from -7 to 7. First, when we're given a graph in the STEM to a free response question, you always want to make sure that any justifications you provide that use the information you're getting from that graph, you always use the name of the graph of f, the graph of f prime, whatever it is. You don't want to use pronouns here. You don't want to say it increases on this interval or it is concave up. Don't say things like that. You want to be specific. Use specific function names. And you definitely have to do this if a question STEM provides you with multiple graphs. In the case where there's multiple graphs, you can't use pronouns because it's not clear. The graph is increasing. Well, which one? So always make sure that when you are using information from a graph and you justify it, you specifically refer to the graph that you're using. All right, the graph we're given is the graph of f prime. So how do we use the graph of f prime to determine where f of x will have a relative minimum? Well, the graph of f of x will have a relative minimum wherever the value of f prime of x equals 0 and changes from negative to positive. We can obtain this information by looking at the graph of f prime of x, since it's given to us. Based on the graph of f prime, we can see that f prime of x is 0 and changes from negative to positive only at x equals -1. That's the only x value on the graph where that happens. Therefore, we can conclude that the graph of f will have a relative minimum only at x equals -1. Part B, find all relative maxima of f on the interval from -7 to 7. Same thinking. The graph of f will have a relative maximum whenever the value of f prime of x is 0 and changes from positive to negative. Again, we can obtain this information by looking at the graph of f prime of x, which has been provided. Based on the graph of f prime of x is 0 and changes from positive to negative only at x equals -5. So we can conclude that f of x has a relative maximum at x equals -5. Part C, we are asked to determine where f double prime of x is negative. Well, in order for f double prime of x to be negative, f double prime of x must exist. This is key, as we will soon see. If f double prime of x is negative, this will correspond to intervals where the graph of f prime of x is decreasing. And again, we want to tie our conclusions to the information that we are given. We are given the graph of f prime of x, so we always want to make our conclusions based on what that information can tell us. Right? So f double prime of x would be negative when the graph of f prime of x is decreasing. We can get that information from the graph provided, and that information is given in the STEM question, or other information in the STEM of the question may be useful for us. Right? Based on the graph of f prime and the given information, f prime of x is decreasing on -7 to -3 and 2 to 5. We are also given that the tangent line is vertical at x equals 3, which means that the derivative doesn't exist there. Right? The second derivative will not exist at that point, right? And the derivative, the tangent line that's vertical is the tangent line to f prime, right? So the derivative of f prime is not defined at x equals 3, so f double prime does not exist at x equals 3. All right. That's why this first bit of information is important. All right, in order for f double prime to be negative, it has to be a number, but it has to be a negative number. Vertical tangent lines, the slope is not defined. It's not a number. All right, so those points would be excluded from intervals where f double prime of x would be considered negative. So taking all that into account, f double prime of x, or the second derivative of f, would be negative on the interval from -7 to -3, 2 to 3, and 3 to 5, and those have to be open at 3 because 3 is not included. Part D, we are asked to find where f of x has an absolute maximum on the closed interval from -7 to 7. Well, we've already determined where f has a relative maximum on that interval. We know the relative maximum happens at x equals -5. The absolute maximum, however, could also maybe occur at one of the endpoints. So we have three candidates for our absolute maximum, either -7, -5, or +7. All right? Based on the graph of f prime of x, f of x is increasing on the interval from -7 to -5. Because of this, because f prime of x is positive on that interval, we can conclude that f of -7 is less than f of -5, right? Because f is increasing on that interval and -7 is less than -5, by definition, f of -7 must be less than f of -5. That's the definition of increasing. Also based on the graph of f prime, f of x decreases from -5 to -1, but not much. And from x equals -1 to x equals 7, there is substantially more increase. From this, we can conclude that f of 7 is bigger than f of -5. Therefore, the absolute maximum of f occurs at 7. The absolute maximum value is f of 7.